In this video, we're going to talk about functions. So functions, in the last video we introduced polynomials. All polynomials are types of functions. So this is just a bit more generality, and we get a bit more notation from it as well, which can be useful. So first of all, a function is a rule that assigns to each element from one set, usually called the domain, exactly one element from another set, which is the range or the codomain, or sometimes the target, depending on what you're talking about. So there are a few ways to sort of visualize what's happening here. Okay, so let's say we have one set over here. So this is going to be our domain set. And then another set over here. Okay, this is possibly our target or codomain. Okay, now maybe in our domain we have the elements A and B. Maybe in our target we have an A, a 1, and maybe a 2. So suppose our function f goes from the domain to the target. Okay, so this is our function. So it might take the element A to the number 1, and maybe the element B gets sent to the element A. So you have to take everything in the domain somewhere in the target. Now, I purposely didn't call this the range, because technically the range is only the things that get mapped to. Okay, so this subset of the target would actually be the range. Another way to visualize it is like a black box. Okay, so here's your sort of function machine. Okay, so this is your f function. And what you do is you put in, say, an x, okay, from the domain. And f is going to do something, and then it's going to spit out, say, a y, which could be the same as x, could be different. And y is going to be part of your range. Okay, here we don't have to worry about target and codomain because we're definitely getting something out of this machine that came from an x in the domain. So this is sort of what's going on. You might be saying, how does this relate to functions that we are used to, like with equations? So we're going to get to that. So like I mentioned, the set of all possible values that can be used as inputs are called the domain, and the resulting set of outputs is called the range. You can think of a function as an ordered pair. So you have the first coordinate is your x from the domain, and the second coordinate is where x is sent. Okay, so this would be what you're used to. So we're getting closer to what you're used to here. So this is from the domain, and the y is from the range. Okay, but we have these ordered pairs. So we can define a function using ordered pairs, and it will tell you what each element does. So in the example below, which of the following are functions where our domain is the same for each? So the domain is the letters A, B, and C. So sometimes it's helpful to think about these with pictures. Okay, so this is our domain. So we know we have A, B, and C in there. So a function has to take everything in this domain, so this is D, somewhere to a different set, which could be D also, by the way. I should have pointed that out. So to each element from the domain. So that means you have to take every element in the domain goes somewhere. Okay, so the function acts on each of these things, and in fact they go exactly one place. Okay, so those two properties are important when we're thinking about whether or not this is a function. So in this example, we don't really know what our target is, so let's see what happens. So remember that the first coordinate is from the domain, and the second coordinate is from another set. So this first ordered pair here says that A goes to an element over here that's also called A. Okay, so this is what F is doing. Okay, now the second ordered pair, again, we take A, but this time it goes to B. So we take our A, and it goes somewhere else this time called B. And then the last ordered pair, again, takes A, but this time we go to a point C. So here the range is actually the same as D, but is this a function? So there's a problem. There's two problems actually here. So this one is not a function, since, so I'm going to give two reasons. So element A in our domain goes more than one place. So that's an issue. And also, elements B and C in the domain go nowhere. Okay, so both of those, either one of those on their own is enough to make it not a function. So let's try another one. So again, we definitely have D over here. So that's our D. And then we're going to have something over here. So in this one, so A gets sent to A. So there has to be an A point in the range. B gets sent to a different point called 2. And C gets sent to another point called Z. Okay, so this one is a function. Since every element in our domain goes somewhere, so it gets acted on, and none go more than one place. So what that would look like if they did, it would be that you had sort of two arrows from one of them out. Okay, we don't have that. Let's look at one more here. Okay, so oops, I'm in my smaller pen. Okay, so again, we have our D. We're going to have some set over here. So it looks like A gets sent to a number 2. B also gets sent to number 2. And C goes to some point Z. So now we want to think, is this a function? So you might be concerned about this part here. So we have two arrows going to the same place. That's actually okay. So this is a function. Okay, it's fine if two elements in the domain go to the same place. The bad thing is when one element of the domain goes two different places. Okay, so that one is a function. Now, what about some sort of more weirdly defined functions? So here, F is a set of ordered pairs where the first coordinate is people and the second coordinate is their astrological sign. So we want to think, does every person have an astrological sign? Because then they're going to be paired with something. And the other thing is, could they have more than one? Okay, so astrological signs depend on your birthday. So once you're born, you sort of fall in a category of astrological sign. So this is a function. Since every person has exactly one astrological sign. Okay, now it's possible and very likely that there's more than one person with the same sign. that's okay, as long as one person doesn't have two signs. That would be a problem. Okay, another one. F is a set of ordered pairs where the first coordinate is a TV show and the second coordinate is a main character. So I would argue here this one is not a function. Since one TV show could have multiple main characters. Okay, so because then a TV show could be paired with more than one y coordinate. So that would make it not a function. Okay, now let's try and move to graphs. So how does this all relate to the functions we're used to? Well, you can use the equation to find the second coordinate given your first coordinate. Okay, so you still have these sort of pairs. It's just that maybe there's lots and lots of x's, possible x's. So we want to determine whether or not each of these is a function with their domain and range. So let's start with the domain. Okay, so when you're computing domain, it's all allowable, unless it says otherwise, I should say. Unless it says otherwise, you should assume it's all allowable x values. So any x value that is not going to cause a problem. So for y equals 2x minus 1, we want to think, can anything bad happen here? So what I mean by bad is like divide by 0 or square root of a negative number, something like this that you know doesn't exist. Can anything bad happen if I plug in any number for x? Well, if I take any number for x and I multiply by 2, that's fine. I'm just going to get some other number. And then I'm going to take that and subtract 1, still some other number. So the domain, if we use interval notation, is going to be negative infinity to infinity. So any real number is going to work. So another way we might write this is with a boldface R, or you might say all real numbers are the domain. Okay, any of those are fine. Now, the range is a little bit harder, so sometimes it helps to draw it if you know. So this one, in fact, we should probably know what it looks like, but we will graph these in more detail later in the course. So here's my coordinate plane. This is a straight line. Okay, it goes through -1 and it has a slope of 2. Okay, so this is what it looks like. Oops. So y equals 2x minus 1 would look something like that. And notice, if I take a point on here, the coordinates are going to be x, y. And y is 2x minus 1. So that's how we find the y coordinate. So, is this a function? Is our main question. So what we want to know is, could we get a different y value for one particular x? So we chose the domain so that all x's will work, so we can plug in any x we want, but could we get two different y values? So let's say I take a random x and then I multiply it by 2. So that's doing this part here. Could that result in any confusion? No, I'm going to have 2 times whatever number I put in. That's a single number. And then when I take that number and subtract 1 from it, I definitely know what number I'm going to. So there's no way to get 2 different y values. Okay, so that means that this is a function. Since for each x value in the domain, so all real numbers, there is exactly one y value with y equals 2x minus 1. So there's going to be 1 point on this line. Now the range for this graph is also all real numbers. Because you can see from the picture, if you wanted, say, this y value, you're going to go to this x value, whatever that is. If you want one over here, maybe you want this y value, okay, it's that point there. So for any y value, you're going to have an x value at that level. So the y is all real numbers. So this is a function. Okay, let's see one that's not a function. So this one's not a function. Now the domain here is a little harder to compute. So I'm going to tell you the domain is in interval notation 0 to infinity, or you could say x has to be bigger than or equal to 0. So why is that? This is because when you have, so the left-hand side of the equation, y squared, this is always a positive or non-negative number. Okay, so if the left side is always positive, that means the right side has to also be positive in order for it to have a solution. Okay, so my x coordinates have to be non-negative. And this graph is a little less obvious, maybe. So when x is 0, y is going to be 0. So we're going to get a spot here. Now, it's actually easier to go from the y's. So when y is 1, 1 squared is 1, so x is also 1. So I'm going to have a point at 1, 1. When y is negative 1, I'm going to have negative 1 squared, which is also 1. So at x equals 1, you're going to have a point for y is 1 and y is negative 1. Okay, this actually works for all of them, and you end up with a graph that's like a parabola, but on its side. Okay, so that's what the graph looks like. So again, the range is all the y values you can hit, which here happens to be all real numbers. But it's not a function. Since, and we already did an example of this, x equals 1 is paired with both y equals 1 and y equals negative 1. Okay, so these 2 points, because they both have x coordinate 1, make it not a function. So when this happens, you actually are going to have a vertical line that hits more than one time. Okay, this is the idea behind the vertical line test. So if a graph is the graph of a function, then there is no vertical line that intersects the graph in more than one place. Okay, so you could intersect one time, you could intersect no times, but there's no vertical line that hits the graph in more than one time, so 2 or more times. So for example, the one here, so this line I drew is x equals 1. It intersected the graph in 2 points. So because that happened, we had not a function. So when you know the graph of the function, it's easy to tell whether or not the graph is a function or not using the vertical line test. When you don't have the function, you're going to have to think about, is there an x value that gives where there's more than one y value associated with it? There's some special points on the graph that we want to talk about. So the y-intercept is the point where the graph crosses the y-axis. So this happens when your x value is 0. Okay, so you want to find y where the function, what the function does at x equals 0. The x-intercept is where you cross the x-axis, and this happens when y is 0. So notice that these things are opposite. Okay, so when you want the y-intercept, you set x equals 0 and find y. When you want the x-intercept, you set y equals 0 and solve for x. So here's another example. Now here we're starting to use some function notation. Okay, so this is important. So I've called these two functions. So the first one is f of x. So x is my input. Okay, and the output that f gives is the result of x squared plus 4x plus 3. Okay, similarly, g of x is equal to the square root of 1 minus 3x. So first I want to know, what is the domain of g? So we want to think, what x values could something bad happen? So because g involves a square root, we're going to need the thing inside the square root to be non-negative. We can never take the square root of a negative. So we need 1 minus 3x to be at least 0. So now I want to solve this for x. So I'm going to add the 3x to this side. Okay, so it goes away on that side. So 1 has to be bigger than or equal to 3x. And then I can divide by 3 on both sides so that I just have x on this side. So I'm going to have 1/3 is bigger than or equal to x. Now remember, if you have an inequality and you divide or multiply by a negative number, you have to flip the inequality. So here I didn't have to do that because I divided by positive 3, but if I had divided by negative, I would have had to be careful. So this means that the domain in interval notation is from negative infinity all the way into 1/3, and then I want to use a square bracket because x could be equal to 1/3. So this bracket includes the endpoint. Okay, because I have the equals there. Now, what is f of 0, and what does it tell you about the y-intercept of the graph? So f of 0 is, this is my input is x equals 0. So in my equation for f, I just want to replace all the x's with zeros. So I'm going to have 0 squared plus 4 times 0 plus 3. So this is 0 plus 0 plus 3. So I get, and my f of 0, this is like the y value at 0. So this would have coordinate 0, 3. Okay, so what it means, remember, for the y-intercept occurs when x is 0. So that's what I just found. So the y-intercept is the point 0, 3. Or you could say the y-intercept occurs when y equals 3. Okay, either of them is fine. Okay, now what about g of 0? So we do the same thing. So here g is 1 minus 3 times 0. So this is square root 1 minus 0. So square root of 1, which is going to be 1. So g has the point, and the y-intercept for that matter, 0, 1. Okay, lastly, what if I wanted f of x plus h? Okay, so that means that my input is actually x plus h. So everywhere we see x, in the formula. So just like we did with 0, everywhere we see x in the formula, we write x plus h instead. Okay, so this is going to be, now I have to remember the formula, so x squared plus 4x plus 3. So instead of x, I have x plus h, all squared, plus 4, now instead of x, I have x plus h, and then plus 3. Okay, so these are to replace x. So notice that if I took out this yellow bit and just wrote x, I have the exact same equation. Now, normally we'd want to expand this out and simplify. Maybe we'll do that. So if I expand x plus h squared, I'm going to have x squared plus 2xh plus h squared. Factor the 4 through, plus 4x plus 4h plus 3. And it turns out that we don't have any like terms here, because the only one that might be, I guess, you might think, is the 2xh and the 4x, because they have the same number of x's, but one of them has an h and one of them doesn't, so we don't put those together. So that's a brief introduction into